Statistics Homework Help. For any help regarding statistics homework help, visit https://www.statisticshomeworksilver.com/ email support@statisticshomeworksilver.com or call us at +1 678 648 4277. Statistics Homework Help. Problem 1. Multiple choice questions. There is only one correct answer for each question listed below. Please clearly indicate the correct answer. There will be no partial credit given for multiple choice questions, thus any explanations will not be graded. Alice and Bob each choose a number independently and uniformly at random from the interval 0, 2. Consider the following events. A. The absolute difference between the two numbers is greater than 1/4. B. Alice's number is greater than 1/4. StatisticsHomeworkSolver.com. 2. There are m red balls and n white balls in an urn. We draw 2 balls simultaneously and at random. What is the probability that the balls are of different color? 3. 20 black pebbles are arranged in 4 rows of 5 pebbles each. We choose 4 of these pebbles at random and color them red. What is the probability that all the red pebbles lie in different rows? StatisticsHomeworkSolver.com. 4. We have 2 light bulbs, A and B. Bulb A has an exponentially distributed lifetime with mean lifetime 4 days. Bulb B has an exponentially distributed lifetime with mean lifetime 6 days. We select one of the 2 bulbs at random. Each bulb is equally likely to be chosen. Given that the bulb we selected is still working after 12 hours, what is the probability that we selected bulb A? V. A test for some rare disease is assumed to be correct 95% of the time. If a person has the disease, the test results are positive with probability 0.95, and if the person does not have the disease, the test results are negative with probability 0.95. A random person drawn from a certain population has probability 0.001 of having the disease. Given that the person just tested positive, what is the probability of having the disease? StatisticsHomeworkSolver.com. 6. Let x be a random variable with 7. X and y are independent random variables with StatisticsHomeworkSolver.com. 8. A number p is drawn from the interval 0, 1 according to the uniform distribution, and then a sequence of independent Bernoulli trials is performed, each with success probability p. What is the variance of the number of successes in k trials? Note k is a deterministic number. 9. A police radar always overestimates the speed of incoming cars by an amount that is uniformly distributed between 0 and 5 miles per hour. Assume that car speeds are uniformly distributed between 60 and 75 miles per hour and are independent of the radar overestimate. If the radar measures a speed of 76 miles per hour, what is the least squares estimate of the actual car speed? A. 72.5 miles per hour. B. 73.0 miles per hour. C. 73.5 miles per hour. D. 72.9 miles per hour. StatisticsHomeworkSolver.com. X. You are visiting the Chilean rainforest when your insect repellent runs out. This forest is infested with lethal mosquitoes, whose second bite will kill any human instantaneously. Assume mosquitoes land on your back and deliver a vicious bite according to a Bernoulli process. Also assume the expected time till the first bite is 10 seconds. If you arrive at the forest at t equals 0, what is the probability that you die at exactly t equals 10 seconds? 11. In order to estimate p, the fraction of people who will vote for George Bush in the next election, you conduct a poll of n people drawn randomly and independently from the population. Your estimator mn is obtained by dividing Sn, the number of people who vote for Bush in your sample, by n, i.e., mn equals Sn/n. Find the smallest value of n, the number of people you must pull, for which the Chebyshev inequality yields a guarantee that. StatisticsHomeworkSolver.com. 12. On each day of the year, it rains with probability 0.1, independent of every other day. Use the central limit theorem, CLT, with no half step, to approximate the probability that, out of the 365 days in the year, it will rain on at least 100 days. In the answers below, phi denotes the standard normal CDF. Problem 2. Please write all work for Problem 2 in your first blue book. No work recorded below will be graded. You take a safari trip to the Poro Balati Game Reserve. A highlight of the game reserve is the Posini River, where one can watch deer and elephants coming to drink water. Deer come to the river according to a Poisson process with arrival rate lambda d equals 8 per hour. Elephants come to the river according to an independent Poisson process with arrival rate lambda equals 2 per hour. On the first day of your safari, you reach the Posini River early in the morning hoping to see some elephants. Assume that deer and elephants are the only kinds of animals that visit this river. A. Let n be the number of animals you see during the first 3 hours. Find E, n, and var, n. B. What's the probability of seeing your third elephant before your 9th deer? C. At the end of 3 hours, you have seen 24 deer but no elephants. What is the probability that you will see an elephant in the next hour? StatisticsHomeworkSolver.com. D. It is now 6 hours since you started watching. You have seen 53 deer, but there is still no sight of an elephant. How many more deer do you expect to see before you see your first elephant? E. Unfortunately, you forgot your camera in your lodge the first day. You come back with your camera the next day and plan to stay at the river until you've clicked a picture of both a deer and an elephant. Assume you're always able to click a picture as soon as an animal arrives. How long do you expect to stay? F. Your friend, a wildlife photographer, is fascinated by the stories of your trip and decides to take the safari herself. All excited, she arrives at the Posini River and is prepared to stay as long as required in order to get lots of beautiful pictures. Unfortunately, she dropped her camera in a bush on the way, as a result of which the camera is not functioning properly. Each time she clicks, there is a probability 0.1 that the camera will produce a faulty picture, independently of everything else. Assume she clicks one picture each time an elephant or deer arrives at the river, as soon as it arrives. Let X be the time, in hours, until she gets her third successful picture of an elephant. Find the PDF of X. Problem 3. Please write all work for Problem 3 in your second blue book. No work recorded below will be graded. Each question is equally weighted at 4 points each. The MIT football team's performance in any given game is correlated to its morale. If the team has won the past 2 games, then it has a 0.7 probability of winning the next game. If it lost the last game but won the one before that, it has a 0.4 probability of winning. If it won its last game but lost the one before that, it has a 0.6 probability of winning. Finally, if it lost the last 2 games, it has only a 0.3 probability of winning the next game. No game can end up in a draw. Consider a starting time when the team has won its preceding 2 games. StatisticsHomeworkSolver.com. A. Graph the minimum state Markov chain model for the MIT football team's performance. Be sure to label all transition probabilities and clearly indicate what state of the world each Markov state represents. You may find it convenient for the below questions to label each state with an integer. B. Find the probability that the first future loss will be followed by another loss. C. Let X be the number of games played up to, but not including the first loss. Find the PMF of X. D. Either evaluate the steady-state probabilities or explain why they do not exist. E. Find a good approximation to the probability that the team will win its 1000th game, given that the outcomes of games 1000 and 1001 are the same. Clearly state any assumptions you use in the approximation. F. Let